And what this material is really we wanted to talk about the profile of a targeted attack. And a targeted attack is different from say, malware or an opportunistic attack or a denial of service attack, in that it is, well, I suppose it's easy to say it's targeted. It is something that involves the penetration of a customer, and we see this across pretty much every customer segment we work with. Governments and government agencies, universities, research labs, every segment of industry, we've seen this happen in. So we wanted to walk through the profile of what these look like, and they vary from incident to incident, from attacker to attacker, but overall we can kind of abstract out a look at what the attackers are doing, what they're going for, and then we wanted to talk about what things customers could be doing to specifically mitigate those attacks. So what we've done is we've broken this down into phases, and then we have in each phase listed out mitigations that we know would prevent, interrupt, or at least help to mitigate that phase of the attack. So this isn't a defense in depth sort of approach. We're not talking about all of the security recommendations that Microsoft makes, but we're talking about specific things when customers say, what can I do to protect myself against directed attacks, against determined human adversaries? What can I do? What would help? These are the big things to us that would help. And then once we get through that, Jim's going to cover some information about what resources do our customers have at Microsoft to work on security problems, and what is that continuum of response. So when we look at directed attacks, it generally falls into this pattern. So it starts with our attacker exploiting a weakness of some sort to compromise some sort of host. This can be users internal to the company who have unpatched Internet Explorer or Flash or Java or something else that we commonly see being compromised, and thus forming a bastion for that attacker. This can be a web server that's exposed to the Internet that provides, that has a vulnerable web application deployed. It can be any way that the attacker has of getting inside that organization. Once they're there, the things they're going to do, they're going to try to elevate their privileges. So they're trying to get from a standard user, if that's where they're at, but generally they start with somebody who's a local admin on the machine. Trying to get from local admin laterally out to more machines in the environment, and eventually get to server admin privileges, exchange admin, database admin, domain admin, enterprise admin. They're going to install malware that allows them to get back into the environment and to do more things. So we tend to refer to this as command and control malware. CNC, you'll hear security people use. Once they get in, they want to establish a secure place for them to come back to and to work from. From there, they're going to mine for more useful credentials and continue to move outward in waves until they get to whatever their goal is. And once that's done, they're going to try to either exfiltrate or delete important data. So let's start at the beginning. This has been something that we've talked about in CSSSec for a very long time, but it continues to be true, and it continues to be critical to our customers. Patching is absolutely key to security readiness. And that's easy on the Microsoft side now, because we've done a really good job with WSUS, SCCM, Windows Update, Microsoft Update. That's a great channel. All of that stuff happens really easily, and happens really is easy to set up and easy to deploy and do. The problem is from those products cover, or those systems, that infrastructure covers Microsoft products, but it doesn't cover third-party products unless they're publishing the manifests for SCCM. And the coverage on that has been somewhat uneven. Some products do, some products don't, some products don't always. So it's key for customers to have a strategy not just to patch the Microsoft bits, but to patch all the bits. And we see whatever is weak, whatever is unpatched, whatever has critical vulnerabilities in it, that's what customers go after. So not to pick on particular pieces, but certainly we see Adobe Reader, Adobe Flash, Java, things that are difficult for enterprises to patch. Attackers tend to go after and use. We also see them go after custom code written in written in environments, or we see them in the web-based sphere. We see them go after a lot of web-based frameworks, things like WordPress or Joomla that are frequently updated and have had security issues in the past. The customer needs a strategy to make sure those things are updated and taken care of as well. So once the attacker's gotten onto one box, they're going to look to elevate privileges from there. The things that we know would break this up, first of all, is that users should not be running as local admin on workstations. Once again, something we've been talking about since Vista came out. But anecdotally, I can tell you I've looked at security incidents excuse me, where an attacker compromised two boxes. On one host, the user was running as a limited user. On the other host, the user was running as local admin. And the attacker, the box that the user was running as limited user on, the attacker did nothing further with. It was useless to them. But the one that they were running as local admin on provided a useful channel for them to go outbound from there and do everything that they wanted to do. So UAC, running as a limited user, these are extremely important because for any user who gets compromised, they limit the potential of what the attacker can do at that point. There's nothing that they can do to jump off of that box and get, or there's very little. I won't say there's nothing, but there's very little that they can do. It really limits their ability to move outward from that one user who browsed that one website that they shouldn't have, or opened that one email that they shouldn't have. The other thing that's key here, because what's going to happen is if the user's running as local admin, the attacker is going to install tools there to try to gather other credentials. Windows Credential Editor is one that's very popular right now. There's something called Mimic Hats that will allow the attacker to get credentials out of memory and use them. So that strategy is dependent on useful users logging into that compromised workstation. So one of the things that we really talk about and hammer home with customers is domain admins, and really any privileged account, but let's start with domain admins. Domain admins should never log into a workstation. They should never log into a member server. Realistically, they should never log in anywhere but a domain controller and potentially an admin workstation that's been set aside for them to work from. Because the domain admin account shouldn't have to do anything other than administer the domain, and the only place they need to log in to do that is a domain controller. If you can do that, then there's nowhere for those credentials to be stolen, because they don't log into other workstations or member servers that might have been compromised where lower privileged users are admins on those machines. So the specific recommendation here is use a group policy to remove logon locally and log on as a batch, log on as service, everything but access this computer from the network for domain admins for all machines except for domain controllers, and potentially special admin workstations are set aside that are appropriately secured. They don't browse the internet. They don't do anything outside of administering domain controllers. And use RDP to perform the necessary admin tasks remotely on the DCs. The next phase we look at is once they're present, they've got elevated privileges, they want to install malware. They want to install something there that allows them to have presence, to reach out through the environment. I was just looking at a piece of malware that specifically has the ability, once they have credentials, to use PSExec to copy itself and run itself on other machines and continue to move outbound. So how do we break this up? The first recommendation on this slide is a really difficult one, but it's also a really valuable one. Application whitelisting, like AppLocker, means that on hosts where that's applied, that machine will only run applications that are whitelisted, that are allowed. So you have a finite list of applications that are allowed. So something that's not on that list, presuming there's not another vulnerability that allows it to be executed, is not going to be able to execute. So PSExec tries to run remotely. It's not on that whitelist. It's going to be blocked and not execute. The malware installer is not on that whitelist, obviously. When it tries to execute, it's not going to run. This is, from a customer perspective, a very large project. It's not easy to do it, and it's not easy to do it right, and there's a help desk kit with it. But in the long run, what we know is that customers who have gone on an application whitelisting journey, if you will, whether they're using AppLocker or a third-party solution, have seen a significant reduction in what an attacker can do because they can't run things that they want to run. The other thing here, and this one's much easier, but it's still not easy, is monitor your antivirus, your anti-malware solution. And I cannot even count the number of security incidents that I've worked on where, whether they were running Microsoft Endpoint Protection or Symantec or McAfee or another party in that space, that they had actually gotten notifications of serious malware on hosts, not just on desktops, but on infrastructure servers, on key critical infrastructure and domain controllers even. The antivirus software generated alerts and said, hey, I found PW dump here. Hey, I found this piece of malware here. And those alerts were never responded to. So the customer had a chance to get out in front of the incident. And it may be weeks or months later that we're working with them to respond. And so attackers had weeks or months to continue on doing whatever it is that they want to do. The other thing that commonly happens and gets missed is that the services get stopped or their configuration gets changed. So once again, this generally generates an alert in the monitoring end of the anti-malware solution, but it's not responded to. And really, customers should be responding to those alerts. It doesn't matter. So the anti-malware service might have stopped because an attacker did it. Obviously, you want to respond to that alert and figure it out. It might have stopped because there's a bug. It crashed. Something bad happened. If that's the case, then you really want to take that, open a case with your vendor, and figure out why it happened and stopped it. It might have happened because a user stopped it because it was something they needed to accomplish and they couldn't do it with the anti-malware solution running. In that case, you still need to respond because you need to understand what the user is trying to do and why your current configuration doesn't allow them to do it and whether or not they should be doing that. So any one of those cases is still something. If anti-malware stops on a host, even if it starts up again later, as an enterprise, you need to be responding to that and understanding what happened and then solving the problem, whether the problem is an attacker, the problem is your software, or the problem is your users. Fix the problem. Don't ignore those and don't let them go by. And the third thing here is keeping signatures up to date because malware is moving very quickly. We're seeing thousands of new threats regularly. If signatures aren't being kept up to date, then you're not getting new threats covered. You're not getting new capabilities in a lot of anti-malware packages. But once again, there's a second thing here, is that if one of the other things that we commonly see malware do on a system is stop signature updates by dropping things in the host file so that the client can't communicate with the update channel, or by stopping services, or by taking other action. So once again, if signatures aren't up to date on a host, that could be a precursor or an indicator of compromise. So making sure that those signatures are up to date and monitoring that update cycle is very important, both from the standpoint of preventing the incident, preventing it from happening entirely, and from being out front of it when it does happen and being able to respond and mitigate it and understand what's happened. So now, once our attacker has compromised a single host, elevated themselves on that host, installed malware, they want to look for useful credentials. And there are a few things we see happen here. The first one is local credentials, things that are in the local SAM, local accounts, local administrators specifically. Many customers, many more customers than I thought, have local administrator enabled and have the same password for local administrator on either all the machines in a particular geographic location, all the machines in a particular department, all the machines in the entire enterprise. This is gold for an attacker, because once the attacker gets on that one box, if they're running as with an administrative credentials or as local system, they can dump the password hash for local administrator and all the local accounts out of the SAM there locally. Once they do that, if that password's the same on other machines, they can connect all of those machines and use that same account, that same local administrator account, to move laterally throughout the environment and compromise significantly more machines. Very dangerous, very difficult, or very easy for an attacker to take advantage of this. So what should a customer do? Use unique passwords for local administrator on every host. Don't say I'm going to, all the machines in accounting are going to have the same password, all the machines in engineering are going to have the same password, all the same machines in Toledo are going to have the same password. Don't do it. It's a significant risk. This is somewhat difficult to administer because the customer has to have some solution for knowing what those passwords are if they need to use them. So the beautiful thing is realistically, in a well-managed enterprise, there's probably no need for the local administrator account. Figure out how to reduce your dependency, remove your dependency on the local administrator account, disable that account entirely, and monitor for usage of it. Because if you've disabled it and told everybody you don't use that, you use whatever the right approach to doing what you need to do is. If somebody's trying to use that account, then they're obviously doing something wrong. And once again, you're out front of the incident. You can go figure out what it is that's going on and why, and then you're ahead of the game. The second thing, above and beyond that, is to deny network logon for all local accounts, which helps to break up. I've had plenty of customers tell me I can't use unique passwords on local administrator, and I can't disable the local administrator account because we use it in some scenario. The help desk all knows that password and they use it, or whatever the case is. We can't disable local administrator because we have a key dependency on it. Or they have other local accounts that are used for some type of service, for some other purpose that also has privilege. You can deny network logon to local accounts. So now if I'm on host A and I compromise the local administrator account and host B has the same password for it, I can't make a connection from host A to host B as local administrator because I would be using a network connection with pass the hash, using the password hash for that account to make that connection and authenticate as that local administrator user. But because access to this computer from the network was denied to me, I can't make that connection and I can't use that account. It's not as effective as disabling the account. It's not as effective as having unique passwords, but is still an effective mitigation strategy to preventing the misuse of local accounts with shared passwords. The other thing is for services. In XPSP2, we introduced 2 new service accounts instead of local system still there, but now there's local service and network service. This is cool because now you have a choice for your services. Either your service has full privileges on the local box, but it can't go anywhere and can't do anything else, or it has limited. Network service runs as a limited user, so it doesn't have full admin privileges to the box, but it can go off the box and authenticate as that computer remotely. So the preference is that services use either local service or network service. There's some additional improvements in this in Windows Server 2012 as well. The other thing that we find quite frequently is never run a service account as domain administrator or another privileged account. This happens way more often than I would like to see. Because if you have stored the credentials locally for that privileged domain account, then those privileges are available on the box. That service is started, so that user's credentials are in LSAS. An attacker who has administrative privileges can grab those credentials and use them, and they can connect to anywhere that service account is available. So once again, there may be scenarios where a customer just can't do that. They have a service that requires administrative privileges across all the boxes in a particular segment of machines. It has to be a domain account. They need to understand that risk, and they need to look at how they can minimize that risk. Is it possible to deny network logon to that machine? Is it possible to set it up so it can only log on to the machines that are part of that group? If that's not, if not running as a privileged account is not possible, then look at how to minimize that privilege and how to also effectively audit that privilege and look for misuses of it. The next phase, once we're, as an attacker, we are on the network, we've elevated ourselves, we've installed malware so that we're there permanently, we've found interesting accounts that we can use to move outward and get to where we want to go. Generally, the next thing we want to see is that we want to copy or potentially delete data. Generally, what we see is attackers copying data. Exfiltrating it is the cool security word that security people are using, taking it out of the customer's network into somewhere else. Recently, there were a few high-profile incidents where in addition to possibly copying the data, the attackers actually deleted large amounts of corporate data and literally destroyed hard drives across tens of thousands of machines in those environments. So there's a few things here that businesses need to do, or enterprises, customers need to do to be ready for this, whether they're losing the data because it's leaving the environment or they're losing the data because it's being deleted. And the first thing is data classification. If you don't know what your data is and how important it is to you, you don't know what to do with it. So customers need to have a policy that goes through and says, this is our important data. These are our crown jewels. This is what we're really worried about. And that should be stuff like intellectual property, obviously anything that could cause a privacy incident if you lost it, your employees' personal details, your customers' personal details, high-value communication inside and outside the company. The customer needs to have that data classification policy. At Microsoft, we use high business impact, medium business impact, and low business impact. But that's just one classification scheme. It's not so much important that it's one scheme or another, but that they know what data exists and where it is and what they're doing with it, and that they have policies to protect it appropriately. For important data, it should be encrypted at rest in some way or another, so that if they lose hard drive images, if they lose the files that contain the data, those aren't very useful to an attacker. Another important thing is that, as possible, high business impact data should be segregated from domain and enterprise administrators. So if you're an IT admin, you don't need access to the data. If you're a data administrator, you don't need access to IT administrative functions. The third thing is use IPsec, or network encryption of some sort, when that data transits a network, to make sure that it can't be captured in flight. And the last thing that is absolutely key and critical is backups. And not just doing backups, but testing the backups, knowing the procedure for getting those backups and getting that stuff back online, keeping the off-site backups, all of those things that we talk about, because I know I have personally worked with many customers who've had very high-profile failures in their backup strategy. And working on security incidents, when one of my customers has a high-profile failure of their backup strategy, that means their data's gone. They have nothing. It's just, and the cost to the customer of losing some data is tremendous. I don't think it's even possible to estimate what the actual impact of losing some things is to a customer. So these are the things, and this is really, if I had one key takeaway from all of these mitigations, this is the single most important. The other things are going to help prevent attacks and break them up and detect them. But if the customer is not dealing with their data properly, their data is their business for a lot of our customers. If they're not doing all of these things, then ultimately, if any of their other protections fails, they're at real risk of having a business-ending event happen. Not just a little security incident, not just, something happened, we don't know what's going on, but of losing all the credit cards that they process for customers, and thus losing Visa, MasterCard, and American Express, using them and thus going out of business, to grab one very public example that happened. So, going back through those mitigations just from the top again, patching. And patching not just Microsoft stuff, because we've made that easy, but patching third-party stuff as well. and having a strategy to do the patching and also to audit that the patching is being done correctly. Another thing that I've frequently had with customers is we come down to understanding that the root cause of an incident was some unpatched application running on desktops, and the customer thought that they were patching this, but they never tested and audited that patching solution to make sure that it was actually done. And so workstations or hosts of some sort were falling through the cracks. The second key mitigation, running as limited user. If you're not running as admin, when you get compromised, there's very little the attacker can do. They can get to your data. They can get to any data you have access to. But they can't run anything as system or local admin on the box unless there's an escalation of privilege, vulnerability, and something on there. But generally speaking, they can't do those things. And it's very hard to move laterally and upward from where you are because you're a limited user. So it's an important concept for enterprises, and it's an important mitigation. Domain admins log on to DCs only, and more generally, privileged accounts should be limited where they log on. Your SQL administrator should never need to log on to a file server via RDP, or to a proxy via RDP, or via local console. The more you can do to slice up and prevent users, allow them to only log on where privileged accounts, to only log on where that privileged account needs to be used, the less of a chance there is for an attacker to get the credentials for that privileged account. Application control, whitelisting, allowing only the applications that you want and certify to running, is going to really reduce the potential for introducing unwanted software. If it's the Wild West, if any process can run, then unwanted software can run just as easily as wanted software. Monitoring and responding to anti-malware. Very important. This is an early warning system. It's not perfect. There are lots of ways in, through, and around anti-malware solutions. But if you're not paying attention to this, and you're not paying attention to when it stops, when it fails, when it reports something, then you're missing a key early warning component of your environment. Protect the local admin, preferably by disabling him. If you can't disable him, make sure you're using unique passwords for every host, and you have some way of getting those unique passwords, whether you have an algorithm that generates it or you have a spreadsheet somewhere that you've protected appropriately, or whatever your approach is. And deny network logon to all of those local accounts, because there's no reason a local account should need to connect over the network to another box. Limits the attack surface, and it breaks up known attacks against local accounts. Limit service privilege. Don't run services as local system if you can avoid it. Don't run services as a privileged domain account if you can avoid it. If you have to do those things, understand the risk and mitigate that risk as much as possible. And the last one, like I said, the big one is protect data. Make sure you know what your data is, where it is. You protect it when it's at rest in storage. You protect it when it's in flight going across your network. You back it up, and you know that those backups are safe, secure, and usable. So, some other things here, just thinking about incidents and security incidents, since that's, we're talking about what's the profile of a directed, targeted security incident. The things we talk to customers about are prevention, detection, and response, and all three of those factor into those mitigations. Some of those things, like I said, anti-malware is an early warning system for detection. Some of these things are preventing either attacks from happening, like patching third-party software, patching Microsoft software, or breaking up the ability, preventing attackers from moving outward from one host to another, from one layer of protection to another. And then having response capabilities is important for a customer, knowing if you have a security incident, what are you going to do, how are you going to do it, and how are you going to go about doing those things. We work with a lot of customers who aren't prepared for that, who have never sat down and said, if a security incident were to happen, who's responsible for these things? What can they do? Who needs to authorize things that are going to happen? If we have to take our Exchange server offline, if we have to take our domain controllers offline, if we have to take our entire enterprise off the internet. I worked on an incident a few years ago that was really illustrated to me the importance of this sort of planning. It was about 1,000 user company, and on a Monday, the folks who monitor the anti-malware noticed that there was one particular department, 3 or 4 machines had gotten infected with something. And so they said, well, we want to take these people offline and fix this problem. And nobody could figure out who had the authority to take them offline, who had the authority to do that. By Friday, all 1,000 machines in the environment were infected. And for reasons kind of too arcane to really dig into, it was a threat that couldn't be easily cleaned. Their anti-malware solution couldn't just clean these boxes and get them back to green. So that company literally took 1,000 workstations offline over a weekend, unplugged the entire enterprise from the internet, rebuilt 1,000 workstations from scratch, redeployed them, and had them back up and running on Monday, which was an amazing effort, and I was very impressed that they pulled it off. But really, if they had been able to respond on Monday, they would never have had to do that on Friday or on Saturday, Sunday, Monday morning. So this sort of pre-incident planning and understanding all of these things is very important, and it's certainly something we can talk to customers about. Once again, sort of what a customer would be doing, and also what we do with customers, and what other customer-facing security orgs at Microsoft do with customers. When we get involved with an incident with a customer, we're starting with an immediate response. We want to help the customer understand, is there a security incident? That's sometimes not in question, sometimes it is. So we're going to start gathering data and understanding, did an incident occur? How did it occur? And trying to interrupt that attack if it's ongoing. And that may involve such things as pulling the entire company off the internet, depending on the level of risk. Pulling if we know how the attacker's getting into the environment or how the attacker's getting out of the environment, blocking those things more surgically. Cleaning up malware that we know to be part of the incident. And then from there, we're moving into a tactical response, trying to mitigate the damage that's been done and get the customer back to green, back to business. And then in the longer term, we want to help them with a strategic response. We want to say, all right, you've been through a bad thing, you lost things, it cost you money, it cost you intellectual property. How do we prevent this from happening again? How do we come through your environment and make sure that you are doing the right things and preventing this sort of thing from happening again? So to really cover that last piece, I want to invite Jim to talk to this. This is sort of a slice of what our customer-facing security teams at Microsoft are. The people that we can get to help a customer with a security incident, from the immediate phase all the way through that strategic phase, as well as proactive stuff. So, Jim, let me turn it over to you.
Yeah, sure. So, ideally what we want to do is we want to mitigate these situations from happening and to assist customers from that happening. And we've got numerous options that are available to Microsoft customers, whether they're a Premier customer or not a Premier customer. And so the different groups that are listed here. So, for example, the PFE, MCS Cybersecurity, ACE, operational consulting teams. There are numerous teams that provide these upfront mitigation and preparedness services. An example of those services is the MCS Cybersecurity team. They've got a solution where they will help a customer set up some of that active monitoring. And they can get very specific. So, some of the specifics that they're looking at is they're looking for application crashes in the environment. Sometimes we frequently say that testing is the bane of the evildoer's existence. The attackers, they don't test their malware very thoroughly, and so there's crashes that happen in the environment. And MCS Cybersecurity has a solution that they'll go in and they'll put in that will specifically look for those type of events, amongst other things, but those type of events. So that's the service that is available to our customers. There's also stuff that is not so specific. It's a lot more broad. So the Premier Field Engineering Group, they've got services where they'll do workshops for customers to help them to understand in more detail a lot of the concepts that Neil reviewed, as well as it'll help a customer to plan out how to respond to an incident, right? So, who's in a leadership capacity, who has the authority to make what decisions, things of that nature that are very administratively focused, but can end up being some pretty big hurdles to responding quickly to these events. There's numerous health checks and reviews that are meant to mitigate. So Premier Field Engineering, CTS, ACE, OpsCon, all those groups have services that are designed to review an environment, whether it's from a development perspective or whether it's from an infrastructure focused perspective. But there's numerous reviews that can be done at different depths and different levels. So there's everything from a security health check that is pretty broad, right? In its current form, it's really meant to look at the Microsoft implementations throughout a whole environment, all the way to the ACE team. They've got a very particular, extremely detailed Active Directory review that they can conduct, where they'll literally spend weeks going through every single little detail and nuance of the customer's Active Directory implementation. And at the end of these engagements, these security health checks and security assessments and security reviews, there's reports that are given to customers, and in all instances it gives the customer a prioritized view of where they need to focus. Now, that's all the preventative stuff that we have, but sometimes it takes a long time to greater than a year to implement all the changes that are needed in total. And so there's services if a customer should get compromised. CTS, which is the group that Neil and I are in, we certainly provide remote investigation services in a reactive capacity, as well as PFE can put resources on site anywhere globally. So we've got teams in numerous different regions. The MCS Cybersecurity team, they've got two in particular teams that go on site anywhere globally. We were able to place them once we got some visas fast tracked. We were able to place them on site in the Middle East, with the resources being sourced from the U.S. in less than a week. And anybody that's traveled to the Middle East understands that getting a visa and actually getting on site in a last-minute effort in under a week is certainly an endeavor. The ACE team can step in a reactive capacity and review, for example, some code, some development code, and provide some really short-term immediate recommendations to customers. All of these groups have reactive services, and they all work together. They're very collaborative and very coordinated in how we respond to customers' situations and customers' events. But then following on those, there are some very short-term changes that almost always, and I'm going to say 99% just to make sure that I give myself an out, but in all instances, there's changes that customers can make immediately to mitigate the the most recent compromise from occurring again, and so you can kind of change the prioritization of things that they should be focused on or should get implemented. And these teams, so MCS, their particular cybersecurity team, ACE and PFE, can help customers to not just design but actually make those changes and implement those changes. Now, there are a lot of headings on the chart here, but the key takeaway is that there's numerous groups within Microsoft services organizations that work globally that can provide customers assistance to mitigate security incidents from ever happening, respond when a security incident does occur, or if one does, and then immediately following up to that, helping to put in some architectural changes or development changes, some mitigations to that situation rather immediately, right? Not something that you plan out 6 months or 8 months down the road or what have you. And so there are a lot of those services that are available that can be brought to bear. So with that, I think we want to open it up to questions to see if anybody has any questions on what Neil presented or on any of the services that the different organizations can provide.
Yep, please feel free either in voice or in chat. Yeah, but as Phil points out in the chat, there's one approach to managing third-party updates. The specific path the customer takes is less important than that they have a path, and that they are both deploying them and checking after the fact that they are properly deployed and effective. So, other questions, comments, concerns?
Hi, Neil. This is Phil speaking.
Hey, Phil.
One concern regarding RDP sessions, just taking the example of the well-known configure malware. As far as I know, that piece of malware was able to reuse admin sessions that were opened on compromised machines by getting the password hash from memory. So at some point we were discussing about RDP session for domain admin accounts. I mean, that is really dangerous in case of a configure class of malware compromise, if I may say. You see what I mean?
So,
because when you log in using RDP, as far as we knew and saw, configure was able to, to reuse the accounts, most likely because he got the password hash, and then further compromise all the machines using that domain admin account. Yeah.
So if you log in via RDP, on the client piece of that, there is not a logon session, so there is not a hash in memory on the client side. On the server side that you connect to, you do create a logon session, so your hash is there. But in this case, that server side is a domain controller. If it's already compromised, then we're not really worried about your password hash there.
Okay.
So to go back one step from that, the recommendation, or what I was saying was, to administer domain controllers, use RDP, preferably from a secure workstation, but that's not always the case, to minimize the risk there. And what's that? The risk that's being minimized is the client you're on. If it's compromised, your password hash for that admin account doesn't get created and put into LSASS locally, so that malware has no access to that. Now, there are other threats there. So, for instance, if that malware had a keylogger, then it could potentially get your password out of what you're typing. That's why we would recommend two-factor authentication for domain admins as well.